Question 2b is what asks us to write the baker's dozen class, which is a subclass of the bagels order item class we just wrote. Baker's dozen object represents an order of 13 bagels, which includes one free bagel. And then it says provide one constructor that takes in just one parameter this time, the price, because we know the quantity. Every baker's dozen is going to have the same quantity, 13. And then it asks us to simply override the bagels order items get cost method to reflect that one free bagel. Then it makes sure to tell us don't duplicate the instance variables of the bagels order item class in the baker's dozen class because, again, it's a subclass. We don't need to override the instance variables or duplicate them. They're already there. We inherit those. So this is going to be a new class called baker's dozen. And since it is a subclass, keyword that we use is extends. Anytime you are a subclass of a superclass, you use the keyword extends. The only other really keyword that we will see would be if you're implementing an interface, in which case you use the word implements the interface like we saw in question 2a. Alright, so this is a subclass of the bagels order item we just wrote, so this extends bagels order item. And that means we inherit the instance variables. We don't have access to them because they're private, but they do exist for a baker's dozen object, a price and a quantity. But we do have access to all the public methods that we see from the bagels order item. So we have access to that get price, get cost, get quantity. We have access to all those methods. The one thing we don't inherit, and you should remember this, is we do not inherit a constructor. So we have to define a constructor for our baker's dozen object here. So we don't need the instance variables, those already exist. When we say extends bagels order item, if there were any new instance variables, we would include those, but just the new ones. In this case, there are no new ones. So we go right to our constructor, the baker's dozen. So this is where we want to set up the price and the quantity. Now the quantity we already know, so we don't even need to take in a parameter there. We just need to take in how much does each bagel cost in that baker's dozen. So the cost is going to be a double variable called price. We could, again, use my price here. I want to use the keyword price. Doesn't really matter what word we use as long as we use correct notation. So we take in the price. Now, can I go ahead and access the price property from the that we inherit from bagels order item? Could I say this dot price equals price, and then quantity equals 13? The answer is no. Even though we have a price and a quantity property, we don't have access to them. Okay. So since those were listed as private, we have no way to change those unless there was a public like mutator method like set price or set quantity, things like that. However, since those methods don't exist in the superclass, the only way we can actually establish those is to use the super constructor. Now you're going to have to look back at your code because I can't pull it back up on the screen. But the constructor for the bagels order item took in a price and a quantity. So if we want to use that constructor to establish that price and quantity, we can call the constructor for bagels order item by saying super. It automatically knows we are referring to bagels order item. So it goes to that constructor, and if you look at that constructor, it needed both properties, the price and the quantity. But we're referring to the new price as price, and the quantity will always be the same thing. And a baker's dozen stands for 13. Okay? Now, if you wonder why it's 13 and not 12, like a normal dozen would be, there's an interesting little anecdote story there at the bottom of page 148. The bottom of this page that shows you why, or it kind of explains why 13 is used as a baker's dozen instead of just 12. It's an interesting little story. So if we say super, and then we pass it two parameters, the price we're going to take from here, and 13, it goes to the bagels order item super constructor and establishes the price and the quantity there because it does have access to those private variables. So that's going to be the only thing we do in our constructor. We are referring to the super constructor to handle those two things. Okay. Now, since this extends bagels order item, it inherits those public methods like get price, get quantity, get cost. We don't need to even write those because they already exist. The only one that's not going to work out, that won't accomplish the purpose we're looking for, would be get cost. Okay, and the code in the in the description of the problem told you to override that method to reflect that one of those bagels is free. So when you order a baker's dozen, you get 13 for the price of 12. So if we don't override the get cost method, it's going to charge us for all 13. So we need to override that method by using the exact same identical method header. Okay, if we do this in a subclass, then it is, in essence, it is overriding the superclass method. So we want basically the original cost, but we want to get one of those 13 for free. So there's a couple ways we could do this. We could say return get price. We could call the get price method to actually get the price of each bagel, and then multiply that by 12, because technically that would be like getting one for free. Or another way we could do it is to, let me leave a little bit of space here, because I'm going to return, I'm going to calculate and return the value all in one step. I could say return, and if I get the cost of the original from the superclass, if I use that original method, if I want access to that, I just say super.getCost. That means go to the method before we override it, which is going to return the cost of all 13 bagels. And then we just want to take one of those bagels off, like get rid of the cost of just one of those. So what I could do is get the cost of all 13 and then just subtract the price of one, and then that in essence is representing one free bagel. So how do I get the price of the original one? Well, I could just say get price, which gets the price of the bagel. Remember, that is a public method I have access to, so I don't even have to say super.getPrice. Since we didn't override the getPrice method, it knows to look for that in the superclass if it doesn't exist here. Okay. The only time I ever really need to use super is if I'm overriding that method. If I say super.getCost, that knows to don't look at this overriding version here. Go to the original one, use it as part of the implementation of the one we're overriding. Okay, so this gets the cost of all 13, subtracts price of 1, so now we actually just have the cost of 12 bagels, which is our purpose. And that's all we do. So that finishes up the class. We've extended the bagels order item, so we wrote the subclass, and it would accomplish its purpose. So there's the class. That's the end of question 2. Time to move on to question 3.